Good morning, dear students. This is Mr. Abdurrahman with another session. Actually, it's another video, a very quick video for another problem to provide by one of the students. And in this problem, as you can see, it's not that clear, but I'm going to try to explain what is needed from this question. It's an algebraic question saying use an algebra, prove that giving three consecutive even number. When I say three consecutive even numbers, one, just a second, 1, 2, 3, they are considered consecutive numbers, okay? But right now I need even consecutive numbers, so I'm talking about the idea that I have, for example, 2, 4, they could be 2, 4, 6. I don't know for sure if they are, but this is the idea. These are considered even consecutive numbers. Trying to explain the idea, okay? And it's saying that the difference between the square of largest number and the square of the smallest number is always 8 times the middle number. He wants you to prove. This is a question of proof. Prove what? Let's say that these three numbers, guys, they are, I'm not gonna say, right now I'm gonna say x, y, z, okay? He is saying that you need to prove that the difference between the first, or actually it's not the first, when he's saying the largest number and the smallest number, it does make sense that it's going to be the first and the last, if you got my point, because 2 is the smallest number in these consecutive, and 6 is the largest. So he wants you to prove that the difference between the biggest number, the largest consecutive even number, and the square of the smallest consecutive even number is equal to, to be more accurate, since we're talking about difference, means that I need to subtract the largest. So think of them as from small to large, like this. Okay, so it means that he wants me to prove that the square of the largest number minus the square of the smallest number is always equal to what? Equal to 8 times the middle one. You get the idea? He wants you to prove, if I said that I have x, y, z as three consecutive even numbers, I want you to prove this, to prove that z squared minus x squared is equal to 8y. But the idea right now is, this is a concept. Right now you're going to use a different way to make it easy for you. Okay, it's not a different way, but the concept is the same. Okay, let's say, since we are talking about the middle number, to make it easy for you to understand, you're dealing with three numbers, right? And the most important one is the a at the middle, because it's the one that is saying that it's equal to something. We're gonna assume that the middle one is gonna be equal to n. Okay, when I say that the middle one is equal to n, it means that the one after it and the one before it, it should be n minus 2, and the one after this number is gonna be n plus 2. If you're wondering why I am adding n to 2, I'm gonna add a small example. If this is equal to 6, guys, it means that when I add 6 to 2, this is gonna be equal to 8. And when I subtract 6 minus 2, this is gonna be equal to 4. You got the idea? So that's why I'm assuming that I'm assuming that the middle one is gonna be equal to n, and the consecutive even number before it is equal to n minus 2, and the one after it is going to be equal to n plus 2. The assumption is saying what? The assumption that's saying that when you subtract the square of this with the square of this, you're going to get 8n. So he's saying that when you subtract the difference between the largest, this is the largest, and the square. Don't forget that it's the square of the largest. He's saying that prove that the square of the largest even consecutive number minus the square of the smallest number is equal to 8n, is equal to 8 times the middle one. Okay? So he wants you to prove that this side is equal to this side. And from the look to it, it's talking about expanding. Okay? And remember, when you are dealing with a plus b square, it said all of that is going to be equal to a square plus 2ab plus b square. And when you're dealing with a minus b square, it's going to be equal to a square minus 2ab plus b square. So you're going to use these two rules to prove the theory. Okay? So now we're going to expand. The first square is going to be what? We're going to expand this, so it's going to be equal to n square plus what? Plus 2n plus 2n plus 4. Okay. Minus. We're going to now add this one here. Minus what? Open bracket. N square minus 2n minus 2n minus 2n plus 4. And don't forget, all of that is equal to 8n, because this is what you're trying to prove. You're trying to prove that all of what is on the right side is equal to what's on the left side. So now we're gonna try to simplify. What do we have? Okay, we're gonna try to merge all of them. Basically, you're gonna start with this. You need to expand this. You need to expand this negative inside of all of the terms. So we will say that n square plus 2n plus 2n. Actually, it's not gonna be plus 2n anymore. We're gonna say that it's equal to 4n, because this was managed in the first step, plus 4 minus n square, and don't forget it's going to be minus. So here what do we have? We have minus 4n, right? But don't forget that we're gonna multiply it by minus, so it's going to be plus 4n and minus 4 equal 8n. Now we're gonna do cancellation. We're gonna cancel what? We're gonna cancel the minus n square with the n square. We're gonna cancel the minus 4 with the plus 4. What's gonna left is gonna be this. So it means that what is left, that 4n plus 4n is equal to 8n. It means that 8n is equal to 8n. It means that proven. Okay, that's the solution for this one. See you in the next video.